Today we will learn the design of two decoders. First, BCD to decimal decoder, that is also called 1:10 decoder or 1:1 out of 10 decoder. Second, we will learn about the design of BCD to 7 segment decoder, or that is also called 7 segment driver. BCD to decimal decoder applications used for driving LED LCD display, that is also used for driving fluorescent and gas discharge displays. To design a BCD to decimal decoder using unused combination of the BCD code as don't care condition. First, we will see the truth table. Consider 4 BCD input as W, X, Y, Z and 10 decimal outputs are 0, D0, D1, D2, D3, D4, D5, D6, D7, D8 and D9. 4 inputs W, X, Y, Z will varies from 000 to 1009, that is BCD number 0 to 9. And for first input, that is when W is 0, X is 0, Y is 0, Z is 0, the output D0 will be high, and for second input when W is 0, X is 0, Y is 0 and Z is 1, that time output D1 will be high. And similarly, for all the 9 inputs, taking the case of 9th, that is when the W is 1, X is 0, Y is 0 and Z is 1, that time the output D9 will be high, and the rest of the input of the BCD, that is from 10 to 15, will be treated as don't care condition, because in decimal we have 0 to 9. Now, the design of combinational logic circuit for BCD to decimal decoder, to realize each decimal output for the corresponding BCD input, we need to take the help of K map. The min terms from 10 to 15 are don't care. Then for decimal output D0, the input for which D0 is logic high is 0. So, we get min terms W bar, X bar, Y bar, Z bar. Hence, the SOP equation for decimal output D0 is D0 equal to W bar, X bar, Y bar and Z bar. Then for decimal output D1, the input for which D1 is logic high is 1. So, we get the min term, that is W bar, X bar, Y bar and Z. Hence, the SOP equation for the decimal output D1 is D1 equal to W bar, X bar, Y bar, Z. Then for decimal output D2, the input for which D2 is logic high is 2. So, we get the min terms X bar, Y, Z bar. Hence, the SOP equation for decimal output D2 is D2 equal to X bar, Y, Z bar. Then for decimal output D3, the input for which D3 is logic high is 3. So, we get the min term, that is X bar, Y bar, Z, and hence the SOP equation for the decimal output D3 is D3 equal to X bar, Y, Z. Then for decimal output D4, the input for which D4 is logic high is 4. So, we get the min term X, Y bar, Z bar. Hence, the SOP equation for decimal output D4 is D4 equal to X, Y bar, Z bar. Then for decimal output D5, the input for which D5 is logic high is 5. So, we get the min term X, Y bar, Z. Hence, the SOP equation for decimal output D5 is D5 equal to X, Y, Z, Y bar, Z. Then for decimal output D6, the input for which D6 is logic high is 6. So, we get the minterm x, y, z bar. Hence, the SOP equation for decimal output D6 is D6 equal to x, y, z bar. Then for decimal output D8, the input for which D8 is logic high is 8. So, we get the minterms y, z bar. Then for the decimal output D9, the input for which D9 is logic high is 9. So, we get the minterm wz. Hence, the SOP equation for decimal output D9 is D9 equal to wz. Now, we get all the SOP equations for D0 to D9. Now, we have to realize this equation using combinational circuit. So, for D0 we will be needing 4 input AND gate and the W bar, X bar, Y bar, Z bar is connected to this AND gate to get D0. Similarly, to realize D1 we will be needing 3 input AND gate and W bar, X bar, Y bar, Z is connected to this 4 input AND gate and we will be realizing D1. For D2 we will be needing 3 input AND gate, X bar, Y, Z bar is connected to this AND gate and we will be getting D2. For D3 to AND gate we will be connecting X bar, Y, Z. For D4 to AND gate we will be connecting X, Y, Z. For D5 we will be connecting X, Y bar, Z. For D6 to AND gate we will be connecting X, Y, Z bar, and for D7 to AND gate we will be connecting X, Y, Z, and for D8 we will be connecting Y, Z bar, and to realize D9 we will be connecting W and Z to the AND gate input, and this way we will be able to realize BCD to decimal decoder. Now, we will see BCD to 7 segment decoder design. 7 segment display is an electronic device which consists of 7 LED arranged in some definite pattern, which is used to display decimal numbers. There are two types. One is common cathode type. In this type of display, all the cathodes of 7 LEDs are connected together to the ground or minus VCC, and LED displays the digit when some high signal is supplied to the individual anodes. Then second type is common anode type. In this type of display, all the anodes of 7 LEDs are connected to battery or plus VCC, and LED display digits when some low signal is supplied to the individual cathodes. But 7 segment display does not work directly by supplying voltage to different segments of LED. First, our decimal number is changed to its BCD equivalent signal, then BCD to 7 segment decoder converts that signal to the form which is fed to the 7 segment display. This BCD to 7 segment decoder has 4 input lines, namely A, B, C and D, and 7 output lines. They are designated as small letters A, B, C, D, E, F and G. These output is given to 7 segment display, which displays the decimal number depending upon the input. This BCD to 7 segment decoder's output through register, it is connected to 7 segment display. The BCD to 7 segment decoder has output A, B, C, D up to G. So, all these output through register they are connected to either common anode or common cathode 7 segment display, and accordingly this logic circuit works. For designing, we have to first consider the truth table. So, we will be considering 4 inputs, they are namely A, B, C, D with A as MSB and D as LSB, and the outputs of decoder, that is 7 segment codes, they are designated as small alphabet A, B, C, D, E, F, G. For the input, when all inputs are 0, 0, 0, so that time the output of decoder G is 0 and all other outputs from A to F are 1. For input 1, the B and C decoder output is high, remaining all other are 0. For input 2, the C and F, these two are at logic level 0 and all other high. This way, for input 3, the E and F are 0 and rest are 1. For input 4, the A, D and E are 0, all other are high. For input 5, the bit output B and E are 0, remaining all are high. For 5 input, the bit output B and E are 0 and all other are high. For input 6, the B is only 0 and rest all other are high. For 7, the A, B, C are high, rest all other are at logic 0. For input 8, all are high, and for input 9, only E is 0, all other are high. Now, coming to the design of combinational logic circuit for BCD to 7 segment. To realize each segment for the corresponding BCD inputs, we need to take the help of K map. The min terms from 10 to 15 are do not care. Then for segment A, the input for which A is logic high is 0, 2, 3, 5, 6, 7, 8, 9. So, we get 2 groups of 8 min terms, that gives A and C, and 2 groups of 4 min terms, that gives B D and B bar D bar. Hence, the SOP equation for segment A is A equal to A plus C plus B D plus B bar D bar. Then for segment B, the input for which B is logic high are 0, 1, 2, 3, 4, 7, 8, 9. So, we get one group of 8 min terms, that gives B bar, and 2 groups of 4 min terms, that gives C bar, D bar and C D. Hence, the SOP equation for segment B is B equal to B bar plus C bar D bar plus C D. Then for segment C, the input for which the C is logic high is 0, 1, 3, 4, 5, 6, 7, 8, 9. So, we get 3 groups of 8 min terms, gives C bar, D and B. Hence, the SOP equation for segment C is C equal to C bar plus D plus B. Then, for segment D, the input for which D is logic high is 0, 2, 3, 5, 6, 8, 9. So, we get one group of 8 minterm that gives A and 3 groups of 4 minterms that gives B bar, D bar, C D bar, B bar C, and one group that gives B C bar D. Hence, the SOP equation for the segment D is A plus B bar D bar plus C D bar plus B bar C plus B C D bar. Then, for segment E, the input for which E is logic high is 0, 2, 3, 6, 8. So, we get 2 groups of 4 minterm which gives B bar D bar and C D bar. Hence, the SOP equation for segment E is C equal to B bar D bar plus C D bar. Next, then for segment F, the input for which F is logic high is 0, 2, 4, 5, 6, 8, 9. So, we get one group of 8 minterms which gives A bar, 3 groups of 4 minterms which gives C bar, D bar, B C bar and B D bar. Hence, the SOP equation for the segment F is F equal to A bar, C bar, D bar plus B C bar plus B D bar. So, the equation of F is A bar plus C bar D bar plus B C bar plus B D bar. Then for segment G, the input for which G is logic high is 2, 3, 4, 5, 6, 8, 9. So, we get one group of 8 minterms that gives A, 3 group of 4 minterms which gives B C bar, C D bar, B bar C. Hence, the SOP equation for segment F is for segment G is G equal to A plus B C bar plus C D bar plus B bar C. Now, we have all the SOP equations for segment A, that is A plus C plus B D plus B bar T bar. For segment B, we have B bar plus C bar D bar plus C D. For segment C, we have C bar plus B plus D. For segment D, the SOP equation is A plus B bar plus C D bar plus B bar C plus B C bar D. For segment E, the equation is B bar D bar plus C D bar. For segment F, the equation is A plus C bar D bar plus B C bar plus B D bar. And for segment F, the equation is A plus B C bar plus C D bar plus B bar C. Now, we have to design a combinational circuit. Now, to design the combinational circuit by which we will able to realize this BCD to 7 segment decoder. So, to realize segment A, we will be needing one OR gate, and that OR gate should have 4 inputs. Then we will be needing 2 AND gate of 2 inputs. So, we will connect A directly to the OR gate, C directly to the OR gate, then B and D will be first connected to AND gate, and then the output of the AND gate is connected to OR gate, and then we will be connecting B bar and D bar to the AND gate, and the output of AND gate is connected to OR gate. Then to realize segment B, for that we will be needing a OR gate of 3 input, and we will be also needing 2 AND gates of 2 input. So, B bar is directly connected to the OR gate, then C bar and D bar first connected to the AND gate, and the output of AND gate is connected to the OR gate. Then C and D are first connected to the AND gate, and the output of AND gate is connected to the OR gate. This way we will be realizing segment B. To realize segment C, we will be needing OR gate of 3 input, and to this OR gate we will be connecting C bar directly, then B directly, and then C directly. So, with this we will be able to realize segment C. Then to realize D, we will be needing a OR gate of 5 input and one 3 input AND gate and 3 2 input AND gate. Okay. So, how we will do the connection? First, A will be directly connected to the OR gate, then the input B bar and D bar, that is connected to the AND gate, and the output of that AND gate is connected to the OR gate. Then input C and D bar, that is connected to the AND gate, and output of this AND gate is connected to the OR gate. Then input B bar and C are connected to AND gate, and output of this AND gate is connected to the OR gate. Then the input B and C bar and D, these 3 input line is connected to one AND gate, and output of this AND gate is again connected to the OR gate. So, for realization of segment D, we actually need a OR gate of 5 input, and to this 5 input we are be connecting this 5 terms, that is A, B bar, D bar after AND gate, C D bar after AND gate, B bar C after AND gate, and B C bar D after AND gate. So, this way we will able to realize the segment C. Then for segment E, we will be needing one OR gate, and that OR gate should be of 2 input. Then we will be needing 2 AND gates, and the input B bar and D bar, that input is connected to AND gate and the output of this AND gate is connected to the OR gate. Then input C and D bar, this is connected to the AND gate and the output of this AND gate is connected to the OR gate. So, this way we will be able to realize segment E. Now, moving to segment F. For segment F, we will be needing a OR gate and that OR gate should have the input 4. So, for this 4 input OR gate, we will be connecting first input A directly, then input C bar and D bar, that is first connected to the AND gate and the output of this AND gate is connected to the OR gate. Then input B and C bar, this input B and C bar is connected to the AND gate and the output of this AND gate is connected to the OR gate. Then the input B and D bar. So, this is connected to the AND gate and the output of this AND gate is again connected to the OR gate. So, to realize segment F, we will be needing 4 input OR gate and to this OR gate we will be connecting this 4 term, that is A C bar D bar plus B C bar and B D bar. So, this way we are able to realize the segment F. Now, next we have to realize the segment G. To realize the segment G, first we will be needing a OR gate. That OR gate should have the 4 input and we will be needing 3 AND gates of 2 inputs. So, to the OR gate, input A is directly connected and the input B and C bar is first connected to the AND gate and the output of the AND gate is connected to the OR gate. Then we will be having input C and D bar. These 2 input are first connected to AND gate and the output of this AND gate is connected to the OR gate. Then we will be having input B bar and C. So, this B bar and C is first connected to the AND gate and the output of this AND gate is connected to the OR gate. So, to realize the segment G, we will be needing 4 input OR gate and to this 4 input OR gate we will be connecting A directly, then B C bar through AND gate, C D bar through AND gate, B bar C through AND gate. So, this way the complete combinational logic circuit of BCD to 7 segment decoder is designed and the circuit is realized. BCD to 7 segment decoder is also called the BCD to 7 segment driver, because 7 segment display cannot be directly connected to the supply, it needs a driver circuit. So, this BCD to 7 segment decoder is basically a driver circuit for the 7 segment display. Now, 7 segment display is also used for hexadecimal number also, but in this case the design of combinational circuit that we have studied or done is for BCD number. So, it is design is restricted for decimal number 0 to 9, but the 7 segment display that can be used for hexadecimal number system also, but for that the complete designing will be done separately. Here we have done the design for 0 to 9 only decimal number. So, this driver circuit is only suitable for BCD to 7 segment drive, and we know that this 7 segment display throughout in various applications it is used for display purposes. In numerous devices it is used. So, this is very important to understand the design of this decoder which we have done, and equally the first BCD to decimal decoder that we have studied, that has also various applications. So, these two decoder, the first one BCD to decimal decoder and second BCD to 7 segment decimal, they both are of very importance. So, we have seen the combinational logic circuit design. I hope you understand, and it will help you lot to further understand the discrete combinational circuit that is used in our digital electronics.